Alright, so in the previous lecture, we looked at a read input registers command and simulated it using modscan32 and modsim32. And it was the same command that we saw, actually data streams, we saw what the data streams are supposed to look like in the previous lecture. And so in this lecture, we're going to look at the data traffic for that. So we're going to compare it with what we anticipated. Okay, so I have modsim32 set up as before. And I just restarted modscan32. A reason I restarted it is for the transaction identifier, and I'll tell you why. So let's click on this button here, show traffic, connect, and there we go. And disconnect. All right, just have a look at this traffic here. This here is our query stream, and in black here is our response stream. All right, so here we go. 1 and this 0, these 2 bytes here, 1, that's our transaction identifier. 00 is our protocol identifier. 06 is the length of bytes remaining or to come in the rest of the stream. And it's of course 1, 2, 3, 4, 5, 6 bytes. 22 is the unit ID. 4 is the function code, which is read input register. 018 is our start address. Remember how we get that address? It's 30,019 minus 30,001, which is the lower limit of read input register of the input registers range, and we want number of registers 1. So what we looked at in the previous section is actually the reality. All right. And then the response, again, transaction identifier 1, protocol identifier 0, 05 is the number of bytes expected back, and of course it's 1, 2, 3, 4, 5. And we have the function code, the unit ID and function code reflected. Then we have the number of data bytes coming back, which is 2, which is 1 and 2 here, and our value of 35 psi. Notice there is no CRC, okay, because the error checking and error handling is taking place in TCP/IP. The IP frame and TCP frame and Ethernet frame we are not seeing here because it's been stripped off by the time we reach this juncture. So we're not seeing all that, and you won't see all that, and you don't need to know about all that. Okay. So let's look again. Let's look now at the second time it queried it, because it's constantly polling it, right? Notice the transaction identifier has changed to 2, and the rest of it is the same. And the response for it, the transaction identifier is 2. If we go again, the third query, transaction identifier is 3, and the response is 3. So every time modscan32 generates a new query and it does what you call a new poll, it will increase the transaction identifier by 1. It'll increment it by 1 so that there are pairs of queries and responses. Okay, so this is what I spoke about earlier, and we need this, the protocol needs this transaction identifier because of the asynchronous nature of Ethernet networks. Things can come in, queries can go out without waiting on responses, and that is why we need that. So very, very important to recognize the transaction identifier and the fact that it increments. Okay.